Hello and welcome to Nurture Academy. In today's module, we are going to learn the quick way to understand molecular orbital theory. So, first thing is, what is molecular orbital theory and how is this theory different from the previous version, which was hybridization theory? So, it's actually very simple difference. In hybridization theory, we have learned that two different atomic orbitals mix together to give rise to new atomic orbitals. Okay, first let us try to understand it very easily. What is the meaning of hybrid? Okay, so in biology actually we have learned hybrids in great length. It is the same concept. Supposingly we have a horse and we have a donkey, and their hybrid is called a mule. If you are taking a male horse and a female donkey, you make a mule, and mule usually will have more strength, more height than a horse as well as a donkey. So same concept is been applying in the hybridization theory. It says that when two orbitals, supposingly we have s orbital which is spherical, and we have another s orbital which is also spherical, they form a new atomic orbital. Then they form a bond which is called a sigma bond. Same way, one s orbital can also mix with another p orbital, and again, you know, the type of bond form will be called sigma. And if you have a p orbital and you have another p orbital which mix together sideways, then again the outcome is a hybrid orbital, hybrid atomic orbital. Okay, so these three will form sigma bonds, but just in case one p orbital and another p orbital, if they mix in this sideways way, then the outcome, since the extent of bonding is very less, so the bond will be called pi bond. In fact, we can notice in here that it does give a lot of appearance of the letter pi. You can see in here very clearly. And if you notice the bonding of s orbital with the p orbital, it does looks like a lot like a sigma bond. Now, coming back to molecular orbital theory. So, molecular orbital theory is a modification version of hybridization theory, because in hybridization theory they say atomic orbital plus atomic orbital will give you new atomic orbital, but molecular orbital theory says that atomic orbital plus atomic orbital should give rise to a molecular orbital, because now we are forming a molecule, not a atom. So now let us, with this brief, let us try to understand this theory better way. So let's see what are the uses of knowing the molecular orbital theory. First use of molecular orbital theory is it will tell you about the bond order of the given compound molecule. Okay, like for example, if you are forming N2 N2 molecule, so you have to calculate and figure out whether there is a single bond between nitrogen and nitrogen, or double bond, or a triple bond. That we can find by using molecular orbital theory. Second thing, we can have a fair idea about what are the magnetic properties of this given molecule. Like whether all the electrons are paired means it will be diamagnetic. If at least one electron is unpaired, means that the molecule would be paramagnetic by nature. So use this molecular orbital theory. All you need to do is you have to mug up this particular energy order. Now, this energy order is applicable only up to nitrogen, not beyond nitrogen. Beyond nitrogen, again, another line we have to mug up. Supposingly, we want to use molecular orbital theory for nitrogen. First thing, single nitrogen has atomic number 7. That means that N2 molecule will totally have 4 electrons. This is the electronic configuration, molecular orbital electronic configuration. So what we are going to do is that we are going to fill 2 electron in each of the orbit and see what happens. So we go sigma 1s 2. So we will fill 2 electrons in each molecular orbit until we get 14 electrons. So 2, 2, 2, 2, 8 electrons are done. 2, 4, 6, 8. 8 plus 2, 10, plus 2, 12, plus 2, 14. That's all. Now, to calculate the bond order, we have simple formula. Number of bonding electron. Bonding electron means those which are without the star. 2, 4, 6, 8, and 10. There are 10 bonding electrons minus number of anti-bonding electrons. 2 plus 2, 4. 10 minus 4 divide by 2. So you will get answer 3. That means that nitrogen and another nitrogen molecule will have a triple bond in them. And magnetic property wise, it is a diamagnetic molecule since it contains all electrons paired. Now, mostly kids are scared about how do you draw the molecular orbital energy diagram. So we are going to draw it in a very simple trick. Get your notebook and pen ready and let's learn that trick. I'm going to go very slow so that you guys understand the concept easily. First, we will write electronic configuration for single nitrogen. Atomic number 7. Electronic configuration would be 1s2, 2s2, 2p3. Now we will just draw one line that will denote one s orbit. We draw at some distance. We will draw one more line. We will say 2s orbit and we will draw another line and we will call it 2p. Since we have N2 molecule, right? So we will same way here we will draw 1s parallel to that side 2s and we go 2p. Now to donate, how many electrons were there in 1s orbit? So there are 2 electrons. We can see that there were 2 electrons. So we will draw here 2 electron. In 2s orbit, also we have 2 electrons. In 2p orbit, we have 3 electrons which have to be filled according to Hund's rule. 1 and 1 and 1 like that. Same way, we will draw for this nitrogen also. Exactly same way. While drawing, you have to know the degeneracy of the orbitals very. Next thing, what we have to do is, in the center of these two, we will write the molecular orbital electronic configuration of nitrogen. We know it has sigma 1s2 that you write here, and then you write sigma star 1s2, and then you write sigma 2s2, and then you write sigma star 2s2, and then you write pi 2px equal to pi 2p by 2. Okay, let's see how do we connect everything together now. See, it's very simple. This 1s orbit and another side 1s orbit. When they mix together with each other, then one bonding and one anti-bonding orbital is formed. Okay, so one is called bonding sigma 1s2, another is anti-bonding sigma star 1s2. Same way, 2s and another 2s, when they mix, you get one bonding and you get one anti-bonding. Okay, here I have made little bit drawing, problem. What we have to do while drawing this orbital, we have to draw it in a way that it is bonding orbital should lie below the atomic orbital, not on the same level or above. Now it is okay. See, 2s is here, 2s is here, and sigma 2s2 bonding orbital has to be below that level. And then lastly, we will connect this and this. Again, as I said, that everybody has to be in the little lower energy level than required. And finally, we can see how beautifully we have drawn the molecular orbital energy diagram for nitrogen. One more time, I'll try to explain you guys. If somebody asks you to draw molecular orbital energy diagram for nitrogen, you draw first atomic electronic configuration of nitrogen on one side. Same thing you have to draw parallel side. After this, in the center of these two, you write molecular orbital energy diagram, sigma 1s2, sigma star 1s2. Only thing you have to pay attention is if you are drawing for 1s orbital, then sigma 1s2 has to be at lower level than 1s. And if you're drawing sigma star 1s, that has to be at higher level than 1s. When you are drawing 2s, sigma 2s has to be lower level, sigma star 2s has to be higher level. And same way, when you're drawing 2p, pi to px, pi to py has to be in lower level. Supposingly, it had pi star to px and pi star to py, you will draw it higher. That's the concept of antibonding orbitals. Antibonding orbitals have higher energy than the parent atomic orbital, and bonding orbital have lower energy than the parent orbital. That's all. And hopefully you have understood molecular orbital theory nicely. By the way, last thing to remember, this one, this energy order is only up to nitrogen. If you want to find out for oxygen, you have to remember another molecular orbital energy diagram that you have to remember. Okay, I'll tell you that one also. Now, if you notice this line again, you have to remember the molecular orbital base electronic configuration for oxygen. Now, if we notice the difference between nitrogen and up to nitrogen, I mean, and oxygen. So, the only difference is that sigma 2pz in case of bigger molecule is actually here. Okay, rest everything is same. So if you can just remember this given trick, molecular orbital theory is actually very easy for you guys. So I hope you guys understood molecular orbital theory. Please tell us in the description box, in your comment section, whether you like this video, and please share and subscribe our channel. Thank you so much. You guys can even request for many more videos like this. Thank you. Have fun. Bye bye.